Okay, let's consider these two equations. For two different lines. So we have this equation, and then we have this equation. 3x minus y equals 8. All right, let's go ahead and graph these. So our first equation here is x plus 2y equals 5. So let's write this in terms of y and just so we have another way of looking at this. So 2y equals 5 minus x. So essentially what I did was go through the algebra on this first one. Minus x over here cancels that. Then we'll divide this by 2, and each of these we'll have to divide by 2 also. So we end up with y equals minus x over 2 plus 5 over 2. So let's set up a table so we get some points here. We have our x and our y values. So it doesn't matter which equation you use, if you use this equation or if you use this equation, whatever you feel more comfortable with. Let's say when x equals 1 up here, we've got minus 1/2 plus 5/2 equals 4/2, which is 2. Y equals 2. If x is 3, 5/2 minus 3/2, so that's 2 over 2 is 1. And let's put one more point in here. The obvious one, if x is 5, y equals 0. So we have 3 points. With a line, we can easily graph a line when we have 3 points. Okay, I put some numbers over here on my Cartesian axis system. So when x is 1, y is 2. Looks like this point here. When x is 3, y is 1. That looks like this point right here. And when x is 5, y is 0. It's this point here. Let's make these dots a little bigger to account for the sloppiness of my scale, my axes. And let's see if we can't squeeze in a line here. It's about right like that. So this line will go something like this. Let's make this point a little bigger. So it takes this one and this one. Okay, 3 points make a line. Easy for us to do. So that's that line. Then let's do this next one. We've got 3x minus y equals 8. So I'll just quickly do this, convert this in terms of y. And we've got y equals minus 3x plus 8. So I changed this around a bit. Corrected my mistake. Y equals 3x minus 8. So let's go with a table here to figure out how to plot this. So when x equals 4, we've got 12 minus 8, or 4, y equals 4. When x equals 3, that's 9 minus 8 is 1, y equals 1. And when x equals 2, that's 6 minus 8, y equals minus 2. So 2 minus 2, 3, 1, and 4, 4. Somewhere around right here. So this one looks then something like this. So maybe we'll call this number 2, and this one number 1. So this is line 2, and this is line 1. Okay, so what's interesting here, so we have these two lines and they cross. Typically two lines will cross somewhere unless they are parallel, unless they're both parallel, unless they're both parallel. Two lines are going to cross. Now, notice that these lines intersect. And they intersect at this point 3, 1. They intersect at 3, 1. So what that means is that these two equations are equal to each other when x equals 3 and y equals 1. That means that if we think of this as a system of equations, system of equations is when you have two or more equations that need to be solved simultaneously. We can find the x value and the y value here that solve this equation by graphing these two lines and figuring out where they intersect. So our solution to our system of equations is then x equals 3 and y equals 1. These two values, this point pair, solves these two equations simultaneously. So you can just, if you want to check again, you can stick these values in, and you'll see that they lead to valid equations. That's how we can solve systems of equations, or more specifically, systems of linear equations. Well, systems of any equations, but in this case, we're only going to be looking at the systems of lines. In the second half of this chapter section, we talk about inequalities. And when we're discussing inequalities, we have some symbols we like to use. Well, we already know for equalities, we have the equal sign. But we have signs like this for inequalities, where you have an angle on its side with the vertex pointing to the left and the open side pointing to the right. Well, this universally means less than in math symbols. And if we reverse this, this means greater than. So just as we can have 3 equals 2 plus 1, we understand what that means. We could also say something like 3 is less than 2 plus 2. And you can see 3 is less than 4. That makes logical sense. Or we could say 4 is greater than 3, depending on how we want to write it. So we can combine the less than and the greater than with equals. So we might have less than or equals. And the or is important because it's one or the other. We could also have greater than or equal.